In this video, we'll practice a function design for a function that takes a compound type as input. We'll use the car type that we designed in the last video. Our problem statement tells us that we want to take a car and a make as a string as input and return true if the car is of the given make. Like always, we'll follow the HtDF recipe and we'll start with the stub, including signature and purpose. We'll call the function isMake, and it takes a car and a make as a string. Its return value is Boolean, as we want to return true if the car's make matches the given make and false otherwise. For the purpose, we'll write returns true if C's make is the given make and false otherwise. For the body of the stub, we need to return a value of type Boolean, so we can return either true or false. I'll choose true, but both are equally correct. The next step in the HtDF recipe is the examples. We want to think about the different ways that this function might be called and what we expect the output to be. Since this function returns a Boolean, we know we want at least one example that returns true and one that returns false. Let's write those now. Let's run those to make sure they don't have syntax errors. And no errors are generated, which is what we're looking for. It does not matter whether the test passed right now, because we only have a stub. We have not finished implementing the function body. We should also consider if there are any other cases that we want to have as examples. I think it would be useful to consider capitalization. Generally, we capitalize the name of car makes as their proper nouns. So I will choose to only accept matching make names that have the same capitalization. I'll write some examples for this. Let's run again to ensure that we don't have any syntax errors. And we don't. The next step is the template. We see from the signature that our function has two inputs, one of type car and one of type string. We need to decide whether we should base our template on the car's template, which is a template for a compound type, or a string's template, a template for an atomic nondistinct. Generally, we want to use the more complex template as it gives us more structure and will be more helpful when we are implementing the function body. So we'll use car's template. Let me copy that now. And at this point in the course, I can delete the stub since we've used it to run our tests. Need to write my note that my template is from the car type. And we can say that this function also has an additional parameter. And we can include that additional parameter in the template. Our template now has all of the pieces that we have access to. The car's make, the car's model, and the make. Now we need to implement the function's body. As we just said, we can see that our template gives us access to all of the pieces that we can work with. We don't need the car's model for this problem, so we can delete it. We can see from the examples that we need to compare the car's make and the make name for equality. Now let's rerun to make sure our tests pass. And they do. So we've completed a function design that takes a compound as input As in all function designs, we used our previous work to help us with the current step. For example, we use the signature to help us write examples and tests. We use the examples and tests to help us implement the function body, and so on.